Hello class, and welcome to today's algebra lesson, which is about sketching graphs and comparing functions. By the end of today's lesson, you will be able to sketch graphs when given appropriate information and compare the important values of functions based on those graphs. So we're going to start with the sketching of the graphs. When you sketch the graphs, they're going to give you some context for the problem, and they're also going to give you important points on the graph. So in this case, in 2015, Christoph Strasser set a new 24-hour cycling record by riding 556 miles in a 24-hour period. The distance he rode over 24 hours can be represented by a function. Sketch the graph to show the distance traveled, y, as a function of time, x. So they're giving you the context of the problem there, and they're also giving you important pieces of information about the graph. The first piece is that the Y-intercept is that no distance was traveled when he has ridden 0 hours. So that means our Y-intercept, our first point on the graph, is going to be 0, 0. Then it says it is a linear function. So that means whatever else I graph from here must be in a straight line. Then it says that it is positive for time greater than 0. So everything is going to be above this x-axis. It's also increasing. So that means our line should be trending up. And then it says the end behavior, once again, is that it's trending up. We need to go back into our problem now to figure out what our other point is going to be in order to make the line. In this case, we have the 556 miles in the 24 hours, which means your second point is going to happen at 24 hours, 556 for the distance in miles. So I'm going to go all the way over to 24, and I'm going to go up to 556, which is just going to be slightly above 550. And then since it is a line, I'm going to break out my straight line, or in your case, a straight edge, and connect those 2 points, increasing, positive, linear, and given our 2 points. So that's what it's going to be like if you are trying to sketch a linear function. Now we're going to look at a couple different non-linear functions. So this first one says a person's happiness can be affected by temperature. Sketch a non-linear graph that shows the happiness of a person as y compared to the function of temperature, which will be x. So the first thing it tells us in this case is that it is positive between 25 and 89 degrees. So that means we want it to be above the x-axis for that time frame, that temperature range. It's going to drop below the x-axis if it is smaller than 25 or greater than 89. It's increasing, so we are trending up until we hit 57, and then we are trending down after we hit 57 degrees. And then it tells us our relative maximum. This is going to be a very important key point here, which is going to be at 57 degrees. The happiness score rating is at 85. One thing we can also do is notice that because it goes from positive to negative at 25 and at 89, those are going to give us our x-intercepts, those values where it changes from the negative values up into the positive values. So I now have 3 points that I can put onto my graph. 25, 0. Notice they're counting by 10, so 25 is going to be in the middle there. And then we've got 89, 0, so almost up to 90, but not quite. And then my third point is at 57, so in between 50 and 60, and up at 85. Once again, they're counting by tens, so I'm going to end up somewhere in the middle here. It said we were increasing for temperatures less than 57. So as I am going from 25 up to 57, it's going to be increasing. And once I hit 57, it's going to be going down again. So your goal then is going to be to sketch this graph as a continuous function. It might take you a couple of tries to actually connect those points. It is even a little bit trickier as I am doing this on the computer. Your line does not need to be perfect, but it should roughly represent what the graph says. Positive from 25 to 89, so we're above the x-axis, below on the outsides, increasing as I go up to 57, 85, and then decreasing after that point. And notice the end behaviors for both is decreasing. So that's one example of a nonlinear function. Another one, we have the number of people in line for a roller coaster throughout the day, can be modeled by a function, comparing the number of people in line Y to the hours that the ride has been open, which will be X. It says that the graph is positive between negative 0.5 and 12, which means that we need to be above X for those values. So above that x-axis, and then negative when it is less than negative 0.5 and greater than 12. So that's where we are below the x-axis. It tells us that it is increasing from, or for anything smaller than 1.4, and also increasing between 5.3 and 9.9. It's decreasing between 1.4 and 5.3, and then decreasing after 9.9. It gives us, in this case, the intercepts. So I'm going to go ahead and put those intercepts on the graph at negative 0.50. We're counting by ones here, so negative 0.50. And then at 12, 0. So I've got 10, 11, 12, 0. And then I have a y-intercept at 0 to 20. This is counting by 50s. So somewhere almost in the middle there is going to be my y-intercept. It also tells us where I have relative minimums and maximums. So this graph is going to be going up and down multiple times. So my relative minimum is going to be at 5.3, so just above 5, and at 133, so somewhere right in here. I also have relative maximums at 1.4, so about 1.5, 448, so just under 450, and another relative maximum at 9, so 9.9, which is basically 10, and then at 643, which is also, again, just about at 650. So I've got all of my dots in place now. Now I want to make sure I'm following that increasing, decreasing part. So it says it's increasing for the values that are less than 1.4. So that means as I'm going up through as I'm connecting these first dots, once again, might take a few tries to actually connect those. As I'm connecting these first dots, it should be increasing until I hit that relative maximum, which means I then change from increasing to decreasing, which is exactly what it says. Once I hit 1.4, I'm decreasing until I hit 5.3. At which point I hit a relative minimum and turn back up to increasing all the way over to my x value of 9.9. Once again, increasing between 5.3 and 9.9. And then dropping back down to decreasing at the x values greater than 9.9 and connecting our last values here as the ride is open. Notice once again then my end behaviors, both of them are decreasing. So some of these nonlinear functions will have multiple curves to them. The other piece that we're looking at today is being able to compare functions. So in this case, the Hawkeye is a computer system used in tennis to track the path of the ball. Use the description of the player's forehand, so the actual sentences here, and the graph of the backhand to compare the paths of the two shots. When you are going through and doing these comparisons, the first thing you should start with is the intercepts. So I'm going to start with my x-intercept. And for the forehand, as I'm going through and reading, I am looking for the value of where it would hit the x-axis, aka where the ball would hit the ground. In this case, that's 58 feet from where the shot was hit. So my x-intercept for the forehand is going to be at 0.58. Then I come over and look at the backhand, and my x-intercept is going to be at 0.70. Then I want to make a comparison between the two. So my comparison in this particular one, I'm going to say that the backhand traveled 12 feet further than the forehand. You could have flipped that the other direction and said the forehand traveled 12 feet fewer than the backhand. Either interpretation is correct, but we want to make some sort of comparison between those points. After you look at the x-intercept, the next thing you can look at is the y-intercept. And in the case of the forehand, it says that the racket, during the forehand, the ball leaves the racket at a height of 2.8. So that means our starting height then is at 2.8 for the forehand. And for the backhand, if I'm looking at this graph, it's counting by ones. It's slightly above the 2 there, but not quite up to 2.5. So I'm going to put that at 2.3, might be at 2.2 or 2.25. I'm going to just call it 2.3. Then once again, we need to make our comparison. And in this case, the comparison that I'm going to make is the ball starts 0.5, not 3, 0.5 feet, 0.5 feet higher for the forehand shot. So again, you can do the comparison in either direction. If you wanted to say the ball starts 0.5 feet lower for the backhand, that is also acceptable. So we start by looking at the intercepts. Those are our first important points that we want to look at. Then we want to look at any relative extremes, so any relative maximums or minimums. In this case, we can tell from the graph portion that we're going to have a relative maximum. So I'm going to look at my maximums here. And in the forehand, it says it travels 29 feet and reaches a height of 10, and then it starts decreasing. So that's going to tell us our forehand, the distance away is 29, and the height of the ball is at 10. And for the backhand, if I look at my graph, I come over here to my maximum point. That looks like it's somewhere between 30 and 40, so I'm going to call that 35. And then if I'm looking at my height, that hits exactly at 7. So I'm going to make my comparison about my maximum, and it is that the maximum height of the ball is 3 feet higher for the forehand. You could flip that around and say the max height is 3 feet lower for the backhand. The last thing we want to look at is the intervals of increase or decrease. And that's again going to come from your maximum. So in this case, I'm going to look at the increase piece because that's how we start the shot. And once again, we're using the values from that maximum. So in the forehand, it starts at 0 and is increasing until we get to 29 feet away. For the backhand, it starts at 0 and is increasing until we get to the 35. So I would say for this comparison, the height increases for a longer time on the backhand, or you could say it increases for a shorter time on the forehand. Last example here, I'm going to have you go through and try a few of these on your own. So we are going to be looking at the fuel economies for two different cars. The first thing I want you to do is look at the Intercept and compare those values. In this case, both cars have an efficiency of 0 miles per gallon at 0 miles per hour, so they have the same intercept to start their graph. The next thing I want you to look at is the maximums, the relative maximums for the graph. Car A has two maximums at 53 and 48. And then car B has maximums that are roughly at 38, 59, and 52. So that means that car B has more maximum efficiencies at a higher maximum efficiency. The next piece I want you to look at is where that first increase in efficiency occurs. So for car A, it's increasing in efficiency from 0 to 25 for that first range, whereas car B is only increasing from 0 to about 13. So car A increases more efficiently in that first interval. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.